Hey everyone, welcome to Data Umbrella's webinar. I'm going to do a brief introduction and then Shivay will do his presentation and we will take questions. If you have any questions during the presentation, please put it in the chat so you don't forget it. This is being recorded and will be placed in our YouTube within a couple of days. About Data Umbrella, we're a community for underrepresented persons in data science and we are a nonprofit organization. This is our team behind the scenes who make it all happen. And my name is Reshma Sheikh. We have a code of conduct and we thank you for helping to make this a welcoming, friendly, professional community for all. There are various ways that you can support Data Umbrella. The first and foremost is to follow our code of conduct. We have a Discord that you can join to ask and answer questions. The Discord link is on our website, and you can also share events and job postings there. You can also make a donation to our nonprofit. We are an open collective, and if you work for a company that uses Benevity, you can also donate via that platform, which provides a company match. You can also subscribe to our Data Umbrella YouTube channel. We have quite a library of videos there now. We have a bunch of playlists. One of them is career advice. Others include data visualization, contributing to open source, series on Scikit, PyMC, and NumPy as well. We have a monthly newsletter. You can find our newsletter at dataumbrella.substack.com, and we aim to send a newsletter on the 1st of every month, and we promise not to spam you. Our website has a lot of resources related to inclusive language, allyship, burnout. Check them out. We're on all social media platforms as Data Umbrella. Meetup is the place to go to find out about upcoming events. YouTube, as I mentioned, has our videos. The blog is where we have posts about what we are up to. And we're also on Twitter and LinkedIn. This webinar uses a platform called Big Marker, and on the very top there are two letters CC for closed captioning. So if you'd like to see a live transcript at the bottom, feel free to click on that. We have a call for volunteers. We add timestamps to our videos, and I'll share the link in the chat. But if you'd like to contribute to adding timestamps so people can find our content, that would be great. We have a few upcoming events in October. On the 11th, we have how to make open source contributions to FastAI, which is a deep learning library built on PyTorch. And we have two events in October as well on Scikit-Image. Today's talk is Machine Learning in JavaScript, an Introduction to TensorFlow.JS. Shivay Lamba is a software developer specializing in DevOps, machine learning, and full stack development. He is an open source enthusiast and has been part of various programs like Google Code In and Google Summer of Code as a mentor, and also has been an MLH fellow. He has also interned at organizations like EY and Genpact. He is actively involved in community work as well. He is a TensorFlow.JS SIG member, mentor in Open Mind and CNCF Service Mesh Community, SOTA Foundation, and has given a lot of talks at various conferences like GitHub Satellite, Voice Global, Facacia or Tech Summit, TensorFlow JavaScript Show, and Tell. And you can find Shivay on Twitter at HowDevelop and on GitHub and LinkedIn at Shivay Lamba. And with that, I will hand over the microphone to Shivay. And just a reminder, if you have any questions, post them in the chat and we will get them answered.
All right. Thank you so much, Reshma, for that wonderful introduction. And I will quickly start sharing my screen as well. So yeah, I think it should be visible now. So I'll quickly just go over to my presentation and we can start. So again, thank you so much for the wonderful and warm welcome. And thank you to the entire Data Umbrella community for for allowing me to share this presentation and share about this particular topic of machine learning for the web. Generally, if we talk about the web, right, we assume that it's just some simple HTML, CSS, and JavaScript that is lying around, and you're just interacting with a lot of static content. But the evolution of JavaScript as a programming language and the versatility that comes with it also helps bring us a lot of applications related to machine learning. So we'll be identifying the need, first of all, for why do we actually need a JavaScript based framework, or like, let's say, some libraries that are specifically bringing machine learning to JavaScript, whereas we have such a and such a big ecosystem for machine learning within other programming languages like Python or Julia, for example. So I'll be covering all of that today in this particular session. So just a very quick introduction about myself in relation to today's topic. So I have been a TensorFlowJS SIG and working group member. That means that I spend a lot of my time helping communities and helping individuals, especially students, to get started with machine learning in JavaScript by conducting workshops, seminars, or talks. And then I've also been mentoring quite a lot of students in open source programs like Google Summer of Code, and also in other few such kind of mentorship programs. So yeah, that's a quick introduction about myself. So of course, the first question is that why, do we need machine learning in JavaScript in the first place? So normally, if we take an example of, if you were to include a machine learning model and you wanted to include that in a web application, the normal way to go ahead would be that you first train your model. Once you have trained it, you'll create the H5 or the pickle file once you have trained it. And then you'll have to use, like, let's say, a Django or a Flask based server. And you'll set up that server where you'll also set up functions for your training, for testing. Now, when it comes to, like, let's say, a tech stack, if you're working with a JavaScript tech stack, and if your entire team is having expertise in JavaScript, then it creates additional dependencies to learn another programming language like Python, just to be able to host this machine learning model and do that inference from this model. And then managing the writing APIs that help you to manage to send the requests and receive the response from this Django server. So there is additional overhead of maintaining a separate server or maintaining like a separate language. So that's one of the biggest asks, that if we are able to, if we have a full stack application that is being built in JavaScript, why not also then remove the dependency of having, like, let's say, an external function, if we are able to add machine learning capabilities within JavaScript as well. So that's one of the biggest reasons why we needed machine learning in JavaScript. And if you're not already aware about what is TensorFlow, so TensorFlow is basically an open source machine learning based library that is created by Google. It is primarily used for it consists of the data flow and differential programming. So essentially, you can think of really large matrices, right? So normally your matrices might be like, let's say, 3x3 matrix. So these are really huge, really big matrices which basically contain a lot of numerical data, and the manipulation of these matrices is what helps us to achieve a lot of the different things that are specifically related to machine learning, especially in the case of neural networks. So that's how TensorFlow is related, right? So we are going to be learning specifically about TensorFlow.JS, which is the open source machine learning library written in JavaScript that you can use to basically have the power of being able to run machine learning models within JavaScript. And one of the other reasons why we actually should include machine learning within JavaScript is actually the versatility that JavaScript as a programming language brings. So, of course, these are some of the most popular platforms that all of us consume, including the browser, server-side, desktop, mobile, and IoT. And what we can see is that you'll find JavaScript being used in all of these different platforms. So whether it's with the browser, with the common web browsers, or it's on the server side with the help of Node.js, you can also create full stack applications on mobile with the help of React Native, whether it's like Android or iOS applications. And on desktop, we have Electron.js. And also for IoT, we have basically on Raspberry Pi, we get a Node.js server as well. So you can see that JavaScript is so versatile that we can basically run it on all these different platforms. And what that means is that since JavaScript can run on all of these different platforms, we can bring in the capability offered by machine learning and on all of these different platforms as well. So you can run machine learning models on the browser or even on IoT-based devices with the help of TensorFlowJS. And of course, according to most of the popular developer surveys, JavaScript is usually the most popular programming language because of the ease of use and the developer adoption that comes with JavaScript. And another great thing that we can do is with the help of JavaScript is that since it is such a versatile language, you can do things such as augmented reality, AR, VR, right? Web3, or let's say sound recognition, conversational AI. All of these can be done with the help of various JavaScript libraries that are available. So you can also combine the TensorFlowJS or machine learning capabilities with all of these different other capabilities with the help of JavaScript to create some really compelling and really intuitive applications. And that is why TensorFlowJS is also a really great tool for creative professionals who might not necessarily have like an engineering background, but they might have relevant web development experience, and they can also utilize TensorFlowJS and not have any prior knowledge of machine learning, and still be able to actually include some really cool machine learning applications for their applications. And we'll see some of these examples today in this particular session. Now, there are primarily three different types of ways in which you can actually run TensorFlowJS, that is machine learning on JavaScript. So the first one is being able to run existing models. Now, these are models that are primarily brought from, let's say, the Python ecosystem, or they're written in JavaScript itself. And here with these existing models, you don't have to do anything at all. So essentially, you don't have to write any machine learning code of your own. These are already pre-built functions that you can directly embed inside of your application, inside of your JavaScript application, and just run the inference from them. And we'll be seeing a lot of these different examples of these existing models that you can actually use. Now, the second one is being able to retrain existing models. So this is what we also known as transfer learning in the entire machine learning space. What means is that we have an existing model, and you basically train it with your own data, so that the model can adapt to the features that are based on your data, and then the machine learning model can adapt to your specific use case. And then we can also actually write machine learning models from scratch directly in JavaScript with the help of specific APIs. So we'll be exploring all of these different three ways. So starting with the one that is like being able to use pre-trained models. So these are just direct, very easy to use JavaScript classes. And we'll see that how easy it is to actually use them directly in your project. Now, some of the pre-existing models that you can find, you can go to tensorflow.org/js/models, and you can find some of the pre-existing models for various different types of use cases, whether it's for doing computer vision, such as like object detection, image classification, or you want to do like text toxicity detection, or like let's say sound recognition. You can find all of them. So we'll just quickly go over to this particular website, which is the tensorflow.org/js, and we'll quickly take a look at some of the pre-existing models. So here you can navigate and explore all these different pre-existing models. All of them are open sourced, and you can take a look at their source code as well. So if we just quickly go and take a look at this image classification pre-existing model, you can see that it is super simple. In case you have some pre-existing knowledge about JavaScript, then it's super easy to get started with this. So over here you can see that in the first couple of lines, we have just imported our relevant modules, in this case with the help of the script tag. In case you're using, like, let's say React, there are dedicated npm packages that you can install. And over here we use basically an image of a cat, and we just load our MobileNet model, which is used for image classification, and we just simply use the model.classify function over the image that we run, and we are able to get our predictions. So you don't need to know what's the machine learning model that is behind the scenes, how does that actually function. you are directly given access to or exposed to the to the training or to the classifying functions that are the end results of the model. So that's how simple it is to get started with some of these pre-existing models that you can directly use inside of your application. So, of course, these are some of the other examples. All of them you can find inside of the TFJS models folder, and we'll make sure to share these examples with all of you and share the links of these URLs with all of you as well. So there are a number of different pre-existing models that you can take a look at and directly embed them inside of your application, inside of your JavaScript application. So those are examples of some of the pre-existing models that you can directly use inside of your applications. And these are, of course, just some real-world examples. Over here, you can see that we are able to do object detection with the CocoSSD model. And it has been trained for over 90 different object classes. Now, there are also solutions today where you can actually train your own custom CocoSSD as well with your own set of training data. That's also possible apart from these pre-existing 90 different classes that come out of the box. Then we have Face Mesh, which essentially is able to locate 468 different facial landmarks on your entire face. And some of the applications that you can see is being used by L'Oreal for being able to test out lipstick colors as well. They are actively using the same model, the Face Mesh model, in their application. And something like body segmentation allows you to specifically detect the human body in an entire frame, and it works for multiple bodies as well. So these are, again, all these pre-existing models that you can directly use according to your own use case. And some of the newer models that we're coming up with within TensorFlow, these include things such as selfie depth estimation. In case you do use Google Photos, you might have seen these kind of effects taking place where you get like 3D photos. This is a new feature that if you use Google Photos, you might have seen, or you can come and you can basically see them. And like these are also some of the other really cool examples of newer models that are actually coming up to be able to achieve these kind of functionalities. Some really cool effects that you can see, including things such as 3D pose. This can be very useful in case you are creating some kind of an application for tracking fitness level as well. So this is able to get the 3D coordinates of the various joints inside of your body. So like, let's say if you were trying to count how many reps a particular person is doing, or if they're actually doing their reps properly or not, you can very easily try to find out that as well. And we are also seeing some other very unique applications, such as being able to animate 3D characters. This is very famous in case of like VTubers. So that also uses MediaPipe and TensorFlowJS. So again, the idea is that since this is really helpful for a lot of creative professionals, you can basically take other different JavaScript libraries as well and combine them with the use case for TensorFlowJS to create some really amazing applications. Some of these examples include like being able to use let's say WebGL shaders with the help of TensorFlowJS to be able to let's say showcase some such kind of amazing applications. Here we have Jason Mays, who's one of the senior developer advocates for the TensorFlowJS team at Google. He created this demo or demonstration where he's able to do teleportation by using WebRTC A-frame, which is used for augmented reality, which is a library written in JavaScript, and 3JS and TensorFlowJS. And here's another one where you're able to do clothing size estimation with the help of TensorFlowJS. And here we have another example of WebXR, which is extended reality, and WebGL as well. So you can see these are some of these small examples where you can combine even other different technologies and create such kind of really engaging and intuitive applications. So that's primarily what we have with respect to our pre-trained models. So the next one that we'll move towards is the transfer learning. So as we discussed, that essentially you're taking some of the pre-existing models and we are basically training them or kind of retraining them on your custom data, right? Based on what a problem statement that we are trying to solve. So we'll train it over our own data, and based on this data, we are able to modify and basically help the current existing model to understand the features of our own data to work better with our data. Now, one of the best examples to get started with this is with the help of something known as Teachable Machine. Now, Teachable Machine is an online tool that, again, requires you to have known existing knowledge of machine learning, and it uses basically neural networks behind the scenes to be able to train on the data that you provide to it, and it provides you ready to use machine learning models. So we'll quickly do a quick demonstration of the teachable machine. Now, primarily, you can start off with either an image project or an audio or a pose. For this example, we will take an example of an image project. We'll just open it up, and we'll go ahead and go over to the UI. So over here, what you can see is that behind the scenes, as I mentioned, that it's using a neural network to do all the training. So first, we'll provide it, like, let's say, two different types of samples classes, right? So, like, let's say if you want to create a machine learning application where we want to distinguish or create like a classification algorithm that classifies between images of either, like, let's say, a water bottle, like in this case, and, like, let's say, a mobile phone in this case. So let's take an example over here for the same. So we'll name our class one as, let's say, mobile phones. And then in case you have, since this is an image based data, so we can either upload, if you have a relevant data available on, you can directly upload the data, or in this case, I'll just record some new data with the help of my webcam. So I'll again, go ahead and do that, and I will bring my phone close to my webcam to, so that it, we can basically hold to record and get like a lot of image. So let's take around 100 different samples. So basically, this is we have taken 100 different samples for our image data. Now let's rename our second one as a bottle, and again, I'll open up my webcam and start recording this with my bottle. So I'll take my water bottle and start recording, and take, like, let's say, again, around 100 images. So this will basically be used as our training data. So once we have done that, in case you are if you want to add more amount of classes, we can do that. So we can actually go ahead and actually do that. Let's say the final class we can take as let's say the mouse. So I'll just call it the mouse. And again, we'll just record some amount of data. So again, I'll use the webcam and start to actually record it. So I'll go ahead and start to record the mouse. Again, let's take around 100 images. So once we have actually done this, right, we just have to simply go ahead and train our model, right? So over here, first, it will take our training data set that we have. In this case, the data that we have created. So we have basically the mobile, the bottle, and the mouse data set, and it will create these three separate training classes. And once it has done that, now it has already started to actually train over these models. So right now it's taking each one of these images and fetching the features of the images, and it's, as we mentioned, right, it's already using a pre-existing neural network that is being retrained, or being we are using transfer learning on this pre-trained machine learning neural network model with our own data that we just created right now. So now we can actually test it out. So let's actually first try to bring our phone. So if I bring my phone over, you can see that it's able to very successfully find out that yes, the prediction class that we are getting as an output is mobile, and it's like 100%. It's giving like 100% prediction rate. If I let's say now bring in my bottle, we should see that. So as you can see that again, very close to highest prediction rate is for the bottle, as you can see. And if I try to bring my mouse over here, again, you can see that it is able to do that pretty well. So with just a few clicks, we were able to create our own classification, image classification model. And now you can actually just go ahead and export this model as well. So you can export it in directly TensorFlow.js or TensorFlow or TensorFlow Lite. And if you just take a look at specifically from the TensorFlow.js side, you can see that again, in terms of the code, it's relatively simple to understand. So here, basically, once we actually go ahead and download this code, it generates two different types of files. One is the model.json file and the metadata.json file. the model.json file primarily consists of the actual machine learning model. So it describes which type of machine learning model was used, what are the characteristics of the machine learning models. In this case, it will be a neural network that we are using. And then over here, we are simply just like, a function first where we are fetching the webcam, and we are basically getting specifically the webcam container HTML element ID. And by using that, we have the async predict function where we use the model.predict based on the value that we fetch from the webcam canvas. So whatever, like, we are recording in the canvas, we are sending that value over here, and we are taking a look at all the different set of predictions, and we are printing the prediction and what's the value of the prediction inside of our function. So this is like very simple to use, and you can directly just go ahead and export this. So you can just directly download this model, and once you download it, it provides this a zip file, and this zip file will basically contain this particular data. So let me just open it up. So over here, what you'll see is that it basically generates the model.json file and also a weights.bin file. So this basically contains the weights of our neural network that are super important. And these are referred to in the model.json, which basically is describing the configuration of our machine learning model. So that is in a nutshell what the Teachable Machine does. Now, I will just want to wait for a couple of minutes and take up any questions in case anyone has any questions. So feel free to ask. I'll be more than happy to take up any questions at this point of time. Otherwise, of course, we'll proceed further with the next section within our session. So in case anyone has any questions, feel free to ask. Otherwise, we'll proceed further.
I think we can go on.
All right, perfect. So that is a quick demonstration about the Teachable Machine. So we'll leave this. Now, of course, this is an example where we only use, like, let's say 100 images in our dataset. Now, in case you have a very large dataset, right? So for that, it's recommended to use Cloud AutoML. This is part of like GCP. So in case you're training on, like, let's say 100,000 images, right? So of course, since the Teachable Machine is a UI based tool, it won't be able to support, like, let's say a million images or 100,000 plus images very well. So for that, you can use the Cloud AutoML functionality, where you can actually upload gigabytes of data and very easily then do the similar kind of model training inside the cloud, and then directly deploy that. So once the training has been done, then you can directly deploy that to TensorFlowJS. So that's what you can achieve with the help of Cloud AutoML if you want to, like, let's say productionize your application and work with a lot larger data set. You can use the Cloud AutoML as well. And of course, this is just a simple example. We have already explored the code where we're just running the in this case, we are using the tf.automl function to basically use the image classification function, and we just use the model.classify to predict what type of flower it is. So this is a small code that how we are achieving it. And then finally coming to the final part, that is like being able to actually write your own code. So if you are, like, let's say an expert with writing machine learning and you don't want to use the existing model, you can actually create your own model as well. So there are primarily two different ways in which you can do that. There are two different type of APIs that are provided by TensorFlow.js. One is the layers API, which is very similar to how Keras is built on top of TensorFlow. So with the help of Keras, we get some additional functions that you can directly import and use them. Of course, if you're looking for being able to edit, let's say, the linear algebra or add your own functions, mathematical functions, you can also use the low-level ops API, which is like the low-level TensorFlow, like the core TensorFlow itself. So there are these two different ways in which you can use these specific APIs and create your own machine learning models from scratch within JavaScript. So if we try to just understand it from this perspective, so you have at the top, right, we have the models. Then these are the pre-existing models, right, the pre-built models that you can directly import. And then we have the layers API that gives us a bit more flexibility in terms of being able to decide on the content, and they provide you a bit more tools than the plain or the bare bones core or the ops API, where you can edit anything that you want. And now when it comes to being able to run TensorFlowJS, TensorFlowJS is supported both on the client side and also on the server side. So on the client side, that means when it's interacting with the browser, or let's say React Native. So there are three different type of backends that are supported. And when I say backend, it does not mean like the server side. It's just a terminology that we use to help make our machine learning model better, like performance better. So you can use like the core CPU of your system, or you can use technologies such as WebAssembly or WebGL as well. And on the server side, we have Node.js, where you can either use the TensorFlowJS CPU or TensorFlow GPU in order to accelerate the performance of your model. So apart from that, you can also specifically use the TensorFlowJS converter that helps you to convert Python-based machine learning models directly into JavaScript models, or of course you can write your own machine learning models from scratch. So coming to the point regarding the client side, where we have different types of backends. So these are the currently existing or the supported backends, like CPU, which is basically the slowest form of execution because this is just using the CPU. WebAssembly is an upcoming technology. Of course, it is primarily focused towards small models. And again, since the basic idea about WebAssembly is that it provides a lot of high performant machine learning, high performant programming language as a direct go-to target for compilation. So you can basically compile a lot of different other high performant programming languages into WebAssembly and use them with these applications. Then we have WebGL that supports for being able to use your GPU as well. And then we have some other upcoming supported backends that are coming in the future with WebNN and WebGPU. So you can select some of these backends dedicated for your machine learning model and use them in order to enhance the performance of your model, in case you're running it on the client side. And just to kind of also compare between the performance of Node.js based, or let's say JavaScript based machine learning model performance with Python based, you can see that they perform relatively similar, right? So here is a model comparison for the MobileNet V2, which is a very popular image classification object detection based machine learning model. And the reason that why TensorFlowJS is performing really well, especially in case of Node.js, because it uses the just-in-time compilation of Node.js. And in some cases, you might see better performance with the help of Node.js than even with the help of Python. In case of the Hugging Face DistilBERT, which is a very famous NLP-based model. So you can see that it's very similar or even better in a number of different times. And the reasons why you should use let's say TensorFlowJS primarily on the front end is, first of all, that you have privacy. So since being able to actually do the machine learning inference directly on the browser side, right, we are not sending any data to a remote server and then using that inference to get it back. Everything is happening on the system of the user. That is why we are having ultimate privacy, because the data is not going anywhere, or it's not getting exposed to any remote server. And then since there's no remote server in mind, there's going to be lower latency, because you're able to very easily just go ahead and run your models and get the results. And there will be lower costs as well, because you don't have to set up a dedicated server. And of course, that will help with the scalability of this. But of course, there are also a lot of different server-side benefits that you should use with the help of TensorFlowJS. So the biggest one being a lot of the larger models might not be feasible enough to even write inside of the client side. So those can be run with more amount of resources, dedicated amount of resources, with the help of the GPU and the CPU on the backend. And then since it uses Node.js, it also gets benefit of the just-in-time compilation that takes place within Node.js. And of course, you're just writing everything within one language, which is in JavaScript, and you don't need separate languages like Python for setting up a dedicated Django or a Flask server. You can manage everything with the help of the backend with the help of TensorFlowJS. And of course, before we move to the resources, I would like to showcase a couple of examples of a couple of code samples that I've prepared for this demonstration. So the first one that I'll show is basically this, and I'll first actually show how that actually looks like, and then we'll proceed towards like what actually is happening. So I'll just go ahead and open up the example. So here, I've just basically used one of the pre-existing CocoSSD models that will help us to detect what type of, or it will try to detect the objects inside of an image that we upload. So the first thing that you can see is the first thing that we get an alert is that our machine learning model is ready. So whenever, of course, you are using any machine learning model that's like TensorFlowJS model inside of your application, it may take some amount of time to load. So what we want to do till then is just wait for our model to load and then actually carry out with the execution. So now since our model is loaded, we'll just go ahead and upload any image of our choice. So in this case, let me go ahead and upload an image. Let's take this as an example, this as an image for an example. So I'll just let's select this particular image. And if I upload this image, so let me just select it. I think probably, I'll just probably change the image because it might not be. Let's go ahead and choose this image. As you can see that what it does is that it is able to detect the bed. It was able to detect the chair. For some reason, it detects this as a laptop. This is a bit strange, but what you can see is that it is able to detect multiple objects within a particular frame, and we can actually let's say go ahead and choose another image as well. Probably this image. We can select this particular image and see, as you can see, it is able to even detect athletes, these persons, and it is able to even detect multiple objects within a particular image, right? So now just to understand the code base and how simple it is to actually get started with this kind of a code base, I will just go to our VS Code. So here I just have a simple HTML, CSS, and JavaScript based application that you see in the demonstration that we have created. So here, what I'm doing is this is my main index.html file. Here, what I've done is I have imported two different scripts. One is the main TensorFlow.js, and the other one is the CocoSSD model. Because since we are using the CocoSSD model, we are basically importing these in our application. Then the next thing that we do is that we have this the button where we want to upload an image, right? So we'll see how we basically use this invoke upload image function inside of our index.js. So basically, this is primarily the main focus where we are getting our canvas that you can see over here. Like this is the main canvas area where we are uploading the image, and once we get the image, we are basically drawing the bounding box on top of the image to be able to detect these predictions and the labels of our predictions. So we'll go back to our index.js. This is our main JavaScript file where all the logic is there. So in the first 10 lines, this is where we are basically loading our model. We are loading the CocoSSD model, and we basically send an alert when our model is ready and it can be used. So that is the alert that you saw at the beginning of the demonstration. And then we have basically just created this particular function, which is used to actually upload an image. So based on the image that we upload, right, we select an image. So we capture that with the help of the file reader, and we are querying and getting that input element which contains our file. And once we get that file, we will basically go ahead and use this model.detect function to be able to detect the image that we are sending to our canvas. And then what we're doing is that once we have done that detection, we are running our predictions on top of that detection. And for that, we are basically using this draw underscore res function that helps us to actually draw these bounding boxes on our target images. So over here, you can see that we have a function which is draw res, which will help us to draw. So over here, we have defining our canvas, and we have primarily two different functions. One to draw a bounding box. So it is able to uniquely detect what are the different types of detections it gets. So it has the coordinates within the image, and using those coordinates, we basically end up drawing our bounding box. So here you can see that we have our 4 different coordinates for our bounding box, x, y, and like x1, y1. And once we get that, we end up drawing an bounding box. And the second function is to draw the label that based on the predictions that we get for our model, we create just a small text to share whichever particular prediction has the highest accuracy, right? So in case we just want to test it out, I'll just also open the console, and you can see over here that if I just refresh this, and we'll just run this again over an image and see the response that we get. So let's say if I take this as an image, right? So if I take this as an image, you can see that it is able to detect the person and the person again. So here is the response over here. So for each one of them, right, it is able to first of all find out what's the bounding box coordinates, right? So these are the bounding box coordinates, and then the class that it gets, and then also the confidence score. So this is basically the confidence score. So it's basically says that it is 98% confident that this is the person. So we're getting the majority class over here, and then similarly you can see the 2 other predictions that we got. We are having the entire set of predictions. So if you were to let's say take an example that had more number of examples over here, so you can see that again this one has more number of prediction results, because the more number of predictions we can get, unique predictions we can get, as you can see. So this is a very simple example of how we are able to use create this kind of object detection algorithm and have less than 10 to 20 lines of actual machine learning code. So most of the code that you see over here, even in these 80 lines, is actually the main JavaScript, where we are using the JavaScript to determine the predictions, right? We could simply just have console log these predictions and not use all of these different functions that we are using to draw the labels and the actual bounding box. The main function that we are having is simply this model.detect function, where we are just returning the predictions from this model, and we are just invoking the model at the start. So this is how simple it is to use some of these pre-existing models, right? Now, I'll also share another example where basically I got this example for if in case you have let's say a dedicated model that you want. So in this case, we basically took we used something known as the TensorFlowJS converter. So I'll just also bring that up. So I'll just open my Google Colab to showcase how that actually works. So what I did was that I created an original Python-based machine learning model on a very famous dataset, which is the Pima India dataset. So let me just actually go ahead and open this up, this particular Google Colab notebook. So the original model was a Python model, right? Which is basically using a Keras-based model, and we are using the Pima Indians dataset, diabetes dataset, which is used to determine whether a person has the probability or has a chance of getting diabetes or not. So you can find that dataset very easily on Kaggle as well. So you can find that dataset very easily on Kaggle. So this is a dataset that we used for this particular example, and again we are just simply sharing or adding the details of our neural network. We are adding our lossless function and optimizer and all. And once you have done and we have ran the predictions, so then what happens finally is that we do a model save to be able to save this tfjs.model.h5 file. So this is our model file that we'll be using. Now, the next thing that we have done, and of course you can see this is the training that is taking place. So this is of course a Python-based model. Now, what we are doing apart from this is that we basically install the Python package for TensorFlowJS, and we basically run this particular part with the TensorFlowJS function, TensorFlowJS converter. And what it does is that it will take your machine learning model that has been written in Python and convert it into a relevant output inside of the TensorFlowJS. And the output that we receive is these particular outputs. One is the model.json file, which basically consists of the information about the model itself. So as you can see that we got this with the help of the TensorFlowJS converter, where we took an existing Python model and converted it into a JavaScript model. And you can see the Keras version, and then of course more details about the model itself. And we also get our weights. Then of course now we are basically using this inside of our JavaScript based application. So in this case, like, this is our index.html, where we are taking like a form details, where we are basically just taking the details which are required by our our training data as well. So not dive too deep into it, but we basically take a list of different health condition values. And once we fetch these values, we basically use this particular function, which is the init function that has been defined in the app.js file. Here, what we're doing is that we are using the tf.loadLayers model. So we discussed about two different types of different type of APIs. One is the layers API and the ops API. So this is one of the examples of your custom machine learning model that you are creating within JavaScript. So here we are using the tf.loadLayers model, where we have defined the model inside of the model.json. And you can see that we are able to even run some predictions by pushing that data into our TensorFlow model. Right over here, you can see the tf.tensor.2d, and we are then going ahead and presenting this result by seeing the output, whether the particular person will get diabetes or not. So that's the prediction, like either 0 or 1, right? So that's the example of how we basically use the TensorFlowJS converter, where we convert an existing Python-based machine learning model. So let's say, just for the sake of it, if I were to actually go ahead and run this, you can see that basically if I run this, and if I run this particular part, we are able to generate the S5 file, and finally we are able to convert that into our model.json file with the existing with the weights, and use them to predict these stocks. So that is primarily another example that I want to share. So yes, those are the main two examples that I want to share. But of course, these by far are not just the only examples. You can actually take a look at some of these other ones in the resources section that we are sharing. So you can visit the main website that is tensorflow.org/js, where you can find some of the pre-existing models, some blog posts, some open source projects that are actively using TensorFlow.js. And in case you also want to contribute to TensorFlow.js itself, the main code is on GitHub, so you can directly go to TensorFlow/TensorFlow.js if you wish to contribute to TensorFlow.js directly. And apart from the TensorFlow.js GitHub code, there is also the Google group in case you're interested in that. But apart from that, we also have the CodePen. So CodePen is a website that provides you a lot of different types of code snippets, and you can directly actually test them, right? So there's dedicated topic for TensorFlow.js. And then there's also Glitch, which provides you a ready-to-use platform for hosting sessions. So basically, you can also use Glitch as well as a platform. And of course, there are some dedicated resources as well in case you are willing to or wishing to get deeper into machine learning with JavaScript. So there are a number of different books, including this one by Manning.com on deep learning with JavaScript. There's also another book by Gant Lebord. So he's also he's a DDE, and he has basically a TensorFlow.js book, which is this Learning TensorFlow.js. This is also a really nice book. You can definitely check it out. And also there's also a TensorFlow.js course on edX for free, which is officially by Jason Mays. So it's basically the TensorFlow.js course on edX. That's also a very famous course in case you want to kick off your career with the help of TensorFlow.js. And if you want to explore TensorFlow.js, there's also a really great course that you can always attend. But of course, these are some of the main resources to get started, or at least seek the motivation on how you can get started, right? Because let's say, even if you're not involved with web development or with JavaScript per se, you can also use TF Lite, which is TensorFlow Lite with other different areas as well. So apart from that, of course, I've already mentioned that this is the edX course on Zero to Hero within TensorFlowJS. You can go and check out this particular course. And the main idea is that, again, you can always join the community by following the hashtag MadeWithTFJS on social, such as Twitter, and you can follow along and get inspiration from some of these really nice, amazing ideas. And of course, these are by no means just the examples. Every week there are some unique applications that people are building. So you can see that by combining the powers of machine learning with JavaScript, given how popular JavaScript as a programming language is and the functions are, so you can definitely check that out and check out the community hashtag, right? And again, so the main idea is that the main idea for this particular talk was also that machine learning really is for everyone, right? So whether you are a beginner in machine learning, you can also still use machine learning inside of your application with the help of TensorFlowJS. So with that, we'll take up the questions now. In case anyone has any questions, feel free to ask. So we'll take up the questions right now.
Shivay, thank you so much. Yeah, if anybody has any questions, they can ask there. I guess a question that I would ask is, does TensorFlow JavaScript integrate with PyTorch as well, or in some way?
So currently, the way you can do this is that in case you have an existing model in Onyx or in PyTorch, you can convert that model into TensorFlow and then use that. So there are some tools that allow you to convert your Onyx-based or your PyTorch-based models into TensorFlow-based models, and then you can import them into TensorFlow JavaScript to be able to use them.
Great, thank you. And I guess another question is how extensive is this application being used? I guess from what I have heard is that almost all in production apps or many in production apps are using TensorFlow. Is that true?
Yes. So just to kind of show some of the biggest examples actually. So if we go to the blog section, right, there are a few blogs that have been published where we are also, if we go specifically for TensorFlow.js, you can see that how some of the even startups and even larger companies are today using TensorFlow.js. So this is one example of RoboFlow where it is using TensorFlow.js for computer vision based applications. Then even LinkedIn is actually using TensorFlow.js specifically for optimizing its performance with the help of Node.js. So this basically uses TensorFlow.js on the server side. So large companies like LinkedIn and even startups today are utilizing TensorFlow, and a lot of different, of course, Android or lower level applications, they use TensorFlow Lite, right, as well, which basically is having a much smaller model size. So of course it's not a very large model as well. So you can see these are some of the just very few examples, and the ecosystem for TensorFlow is evolving. Right, 1 year back, it is primarily used by smaller startups. Now we are also seeing full-fledged companies also using TensorFlow.js inside of their projects. So Intel, Intel or even VMware, these kind of companies are also contributing directly to TensorFlow.js, and they're also using them internally.
Great, thank you. I see we have no questions. So, if you, thank you so much for presenting. And if you have any last words, feel free to share.
Yeah. So primarily, again, the last word that I had was that, of course, if you want to reach out to me, you can always reach out to me on my Twitter. But this is a really great time to get into the ecosystem for JavaScript and web, and the web ML, which is basically machine learning web in web. So in case you're interested, especially if you're a student or even an early working professional and you're interested to kind of work with machine learning and try out machine learning. So this is a really great point of entry to get started with understanding the machine learning development and with machine learning based applications, since it is more focused towards beginners, right? and on how to use machine learning inside of their web applications. So it's a really great tool to be able to do that. So yeah, I mean, that's what I would want to probably stop here with this particular thought in mind. But yes, there are tons of resources as well, including the course that is there by Jason Mays from the official Google TensorFlow team. So you can also check it out in case you're interested. But yeah, I would like to conclude with that.
Thank you so much.
Thank you so much. Yeah.